All right, in this video, we're ultimately going to be trying to, at the end, we're going to be trying to find zeros of a polynomial function algebraically without having to graph. All right, so we're going to be using synthetic division to do that. So first, let's just look at dividing using synthetic division. Okay, so there's two ways you might write a division problem. One of them is using the divided sign like that. One is using that horizontal fraction bar. Both of them are just division. All right, so when you're doing this, what you're going to be doing is taking the x minus 2 and thinking what the 0 would be associated with that. Thinking about x minus 2 equal to 0 would mean x would equal 2. So 2 is going to go in the box. Okay. Now, what you're going to do is look at the other factor and take the coefficients of those terms. So we have a 3, a -3, a +7, and a -1, and no terms were missing. So we didn't have any missing terms on that one. So that would be it. All right, then you're going to leave a space and draw a line. Whatever the first number is, you're going to just bring that down, okay? Then you're going to multiply 2 times 3 and write the result in the next column. Then add straight down, you get +3. Then do 2 times 3 and write the result in the next column, and then add straight down and get 13. And then do 2 times 3, which is 26, and write that right here, and then add straight down and get 25. Now, later, when we use this to find the zeros of a polynomial, the fact that the remainder, that the part in this box right here was 25, means that x minus 2 was not a factor. Okay, so this right here being 25 means that x minus 2 was not a factor, or that 2 was not a solution to the polynomial. Okay, it's not what you're being asked here, though. Here you're being asked to write your result. And when you do this, you're going to write your result like you would if you had divided, say, the number 7 by 2. You know, 2 goes into 7 3 times, and you have a remainder. So you could say that 7 divided by 2 equaled 3 and 1/2. We're going to do the same thing here. The quotient is this part right here. So you're going to write that it's 3x squared, and it's x squared because I was dividing by x. I had a cube and I was dividing by x to the first, so that means that's going to be 3x squared. This is going to be plus 3x plus the constant 13, but I had a remainder. So then I'm going to do like we do there. We take the remainder and we put it over our divisor, but your divisor being the x minus 2. So that's what should be written in this box, all of this, okay? Quotient plus remainder over divisor. Okay, so let's try another one. This one I'm dividing by the factor x minus 1. X minus 1 would equal 0 if 1 were put in there. So the factor x minus 1 corresponds to a root or a solution of 1. That's what goes in the box, okay? Then this one you have to be careful because we're missing an x to the 4th. We're also missing an x squared and an x. So we're going to have some placeholders. So the coefficient on x to the 5th is 1. Then the coefficient on x to the 4th is 0. On x to the x to the 3rd is there, and the coefficient of it is 6. There's no x to the 2nd, so its coefficient was 0. There's no x, so its coefficient was 0, and then we have a constant. So this one had a lot of missing terms. You need to be sure to put in those placeholders. Then leave a space and draw your horizontal line. So now I'm going to bring down the first number, and then I'm going to multiply 1 by that, get 1, and add straight down. 1 times 1 is 1. So then when I add straight down, I get 7. Now 1 times 7 is 7. Add straight down is 7. 1 times 7 is 7. Add straight down, I get 7. And 1 times 7 is 7. And when I add straight down, I get a 0. All right, this is always your remainder here, okay? And this part right here is your quotient, gives you your quotient. We are dividing by an x to the first power. We started with an x to the fifth. So this would be a 1x to the fourth plus a 1x to the third plus a 7x squared plus a 7x plus your constant. You can also get what that is by knowing that whatever's the first number you have to the left of the remainder is your constant. And since the remainder was 0, we don't really have to write the remainder over the x minus 1 because that would just be 0. So what would go in the blank here would be this part right there. Okay. Now because the remainder was 0, that means that x minus 1 was a factor. So it means that this right here, even though we would have had no idea how to factor it, that x minus 1 is a factor. It factors into that and then all of this stuff that we had. Okay. It means that 1 really would have been, if I did have an equation, this is going to come later, so I'm just highlighting what's going to happen. If I were trying to solve that, I just found out that 1 is one of the solutions, that x equal 1 would make that true, and it would be one of my solutions. And then I could go looking for others. Okay? All right. So that one was just doing the synthetic division and then rewriting or writing your answer in the form quotient plus remainder over divisor. Now, here's a couple things that you can do if you know what the synthetic division is really doing. All right, so here, synthetic division could be used to find the value of the function at -4. Okay. All right, that's actually what the remainder really does. So let me back up a minute. So this right here is actually the value of the function at 2. And because the value of the function at 2 was not 0, that meant 2 was not an x-intercept. Okay, this right here was the value of if f of x were equal to x to the fifth plus 6x to the third minus 7, that spot right there would have been the value of the function at 1. And it did equal 0. So that meant 1 is a solution of that, is a 0 for that function. It's a solution of the polynomial equation. Okay. But that remainder really is a way of, it gives you a way of evaluating the function. So of course I could just plug in a -4 everywhere, right? I could do 5 times the -4 raised to the third power and so on. But I can also just let -4 go in the box, put my coefficients down, make sure if there were any missing terms, you'd put in a placeholder, but there weren't any missing terms. Bring down the first number and then get to it. So 5 times the -4 would be -20. -20 and -6 would be -26. So now I need to do the -4 times the -26, and that would be a positive. And let me not mess this up. 26 times 4 is a positive 104. When I add straight down, I would wind up getting a positive 99. And then when I do -4 times the 99, I get -396. And then when I add 6 to that, I get -390. So that's the answer. Okay. So the value of the function at -4 would be -390. If I ask you to use synthetic division to find the remainder, then you would have to show this here. But there's no reason why you couldn't check it by plugging in the -4 everywhere for x. There's no reason why you couldn't do that as a check. but it actually is pretty quick to just use synthetic division. Okay? All right, now, here's the real reason you're learning synthetic division. Okay. On this one here, it says use synthetic division to divide the polynomial by x plus 1, and then use the result to find all the zeros. Okay. Now this is here because they want you to show your work. So they want you to show what you get when you divide by x plus 1. But in reality, we're ultimately trying to find all of the zeros. So when we are looking at this, we're dividing by x plus 1, then that means that -1 is going to go in the box. Then we're looking at the coefficients of the function. So it would have a coefficient of 1, then -5, 2, and then 8. Leave a little room and put your line. Bring down the 1 and then do the work. So you'd get a -1, add straight down, get -6. Then you'd get a +6, add straight down, you'd get 8. And then -1 times 8 would be -8, add straight down, you get a 0. That 0 that you get right there is just telling you that -1, that this -1 was one of the zeros of the polynomial. So this remainder being 0 is important. Okay, it means -1 actually is a 0 of the polynomial. All right, now what they want in the box is the fact that this turned out to equal x squared minus 6x plus 8. They're trying to get at the idea that when you use synthetic division and your remainder turns out to be 0, then the x plus 1 factor, okay, really was a factor of the polynomial, and then your result, the x squared minus 6x plus 8, is the remaining factor. Okay, so now that we know that, x plus 1 was a factor and we have this x squared minus 6x plus 8, what we are going to do is finish it up by either factoring or using the quadratic formula. So we're going to check this one. Yeah, that'll factor using a 2 and a 4 if we make them both negative. So that means we got the -1 already. Then this would be a 0 of 2, and x minus 4 would mean we'd get a 0 of 4. So -1, 2, and 4. All right, so really back to the idea from here to the answer. The idea is that if x plus 1 really is a factor, that means if you get a remainder of 0, then you can use these three numbers. They're giving you the other factor, and it's just a quadratic. So that's basically your A, your B, and your C. If it's factorable, that'll be the quickest way of doing it. If it's not, you could use the quadratic formula. Okay, so let's try another one. So on 38, I'm being asked on that one, let me erase those. Write those a little higher. Okay. All right, on that one, I'm being asked to solve this equation. Okay. I know one of the zeros is -4/3, but I'm going to use synthetic division to try to break up that polynomial so that I can find the remaining zeros. So here's what I'm going to do. I'm going to put the -4/3. Let me make that a little smaller so I have room to show my work over here to the side. The 0 is what goes in the box, -4/3. Then I'm going to put my coefficients, 36, 45, -7, and -4. Okay, leave a space, draw your line. Bring down the first one. Now take 36 times -4/3. You can just use the fraction keys on your calculator, or you can take the 36 times 4, get that, divided by 3, or you can do it by hand, because 4/3 times 36, 3 goes into 36 12 times, so I know that would be a -48. All right, now I'm going to add straight down. So that was these two multiplied, and that gave me -48. Now add straight down, I'm going to get a -3. So when I multiply -4/3 times -3, that's going to turn out to be +3 12/3 or positive 4. Negative 7 and positive 4 would be negative 3 again. Okay, and then when I do negative 4/3 times negative 3, I get positive 4. When I add straight down, I get a 0, and I would have to get a 0. I would have to get a 0 because they told me that this is a 0. So it should have a remainder of 0. Then the 36, the negative 3, and the negative 3 are actually the A, the B, and the C. And I need to go on and solve that. Now that one with the 36 right there, that one, gosh, 36 has a million different factors. So that one would be kind of tough to do. You might try a quick, like I might try 6x and 6x, maybe with the 3 and a 1, and that doesn't work. Maybe I'll try one more, maybe like a 9 with a 4. Okay, but there's no guarantee it's actually going to factor. And so, you know, sometimes all this trial and error stuff sometimes can take up too much of your time. Actually, I think that one would work, wouldn't it? Because there would be 12x and there would be 9x. But that's one where you probably would have just gone on and used the quadratic formula. So I think that's what it's going to turn out to be. But let's go ahead and just do, on that one with 36 having so many possibilities, it's okay to just go right in and do the opposite of negative 3 plus or minus the square root of negative 3 squared minus 4 times A times C. All of that divided by 2 times the A. So you wind up with a 3 plus or minus square root of 9, and then a negative times a negative turns out to be plus something, and you get 4 times 36 times 3, which is 432 over 72. I have to keep going. 432 plus 9, that's going to give me 441. And 441 is a perfect square. So when I do the square root of that, I do wind up getting a nice number. I get 21. So then I'd have to separate that into 3 plus 21 over 72. Then I'd have to do 3 minus 21, which would be negative 18 over 72. And then simplify that. So 24 goes into 72 3 times. And with 18, does 18 go into 72 evenly? Yeah, that would be a negative 1/4. So we'd get a positive 1/3 and a negative 1/4. So for your solution set, don't forget that negative 4/3 is one of them. And then we have a positive 1/3 and also a negative 1/4. Okay. All right, and then that one would have been able to be factored, I found, if I had used a 4x and a 9x. Okay, and I just thought of something I should have realized I could have done that would have made it easier for myself. If I were going to try to factor, I should have taken these numbers and thought to divide through by 3, because I'm allowed to do that, and that would have made the numbers smaller. Okay, but anyway, if I hadn't thought to do that, I could have still have factored it. I would have had to work on getting the signs right. Okay, and then once I was sure, I could set each of those equal to 0, and that would have been the negative 1/4. This would have been positive 3/9, which would simplify to be 1/3. Okay, but again, on this one, I just didn't notice it ahead of time. But now that I'm looking at it, do you notice how 36, 3, and 3, I could have factored out a 3 from all of those, which would have made the factoring a little bit easier. Okay. All right, but it doesn't matter. All right, so that's that one. Let me go ahead and just do these other two in this same video so I don't have to do another one. All right, so I'm going to go ahead and do these last two now. So let's take a look at those. So that all goes with question number 39. So let me go ahead and look at, number 38. Let's go ahead and look at number 39. So this one says, if we know 4 is a 0, find the remaining zeros. Okay. So let me go ahead and work that problem out. So I would put 4 in the box, and then I would write down all the rest of the factors. I would leave a little space and draw a line and then go through the synthetic division process. So you take a moment to do this as well. It's kind of self-checking. If they tell you 4 is a 0, then you know the remainder should turn out to be 0. So now what I have left is x squared minus 4x plus 20. Okay, and I'm trying to solve that. I'm trying to find out what causes that to equal 0. So I could try some factoring, but there's no guarantee that it really factors anyway. But you might just try a couple, like 20 is 1 and 20, 2 and 10, okay, or 4 and 5. And it looks like none of those are going to give me the middle term I need. So I thought about it, but it doesn't seem like it's going to work. All right, so let me go ahead and use the quadratic formula. I'm going to do that right here. So it'd be the opposite of negative 4 plus or minus the square root of, I need a little more room. Okay. Let me just erase this. Sorry. Let me see if I can get that erased more quickly. Let me erase all the ink and just start over again on that. Okay, let me start over again on that one. So what I'm going to do is put the 4 in the box, write down those coefficients, do the synthetic division process, and find what I already know, that it's going to have a remainder of 0. Then I'm going to take the x squared minus the 4x plus the 20, and I'm working on what causes that to equal 0. Okay. All right, so I would think about factoring, but like I mentioned before, 1 and 20, 2 and 10, 4 and 5, there's no way to get that middle term. So I'm going to use the quadratic formula, do the opposite of the middle term, plus or minus the square root of the b value squared, minus 4 times a times c. All of that divided by 2 times the a, and then simplify that. So I'm going to get a 4 plus or minus, and a 2 down here. Underneath the radical, I'm going to have positive 16, but then minus 80. That's why it didn't factor. I'm going to have an imaginary solution there. Let's see if I can get that to move up a little bit. Okay. All right, and so underneath the radical, I have a negative number. So that's going to wind up being negative 64 underneath here, okay? So that's going to be 4 plus or minus 8i over 2. And 2 goes into both 4 and 8, so I can divide it into both of those and get 2 plus or minus 4i. Okay, so that's why it didn't factor. So this one says remaining zeros, so we wouldn't actually put the 4 in the box, and then we have 2 plus or minus 4i. Ooh, I didn't simplify far enough, it just hit me. No, I did. It was only divided by 2, right? Let me double check the coefficient. Yeah, divided by 2, so it's 2 plus or minus 4i if they have the plus or minus option. If not, put 2 plus 4i and then copy it, paste it, and then switch it to a minus. Now there's really 3 zeros like there should be. There really are 3 zeros, but one of them is the 4, and in this version they asked me not to put that one. All right, then I just wanted to remind you that those questions earlier where we were looking at zeros and their multiplicities, all right, that those were actually, we're also solving. So we're also, earlier when we were finding zeros and their multiplicities, we were actually taking this problem right here and finding what caused it to equal 0. So when we do that, we actually are going to set each of these factors equal to 0. Okay, and solve, it's just on the earlier ones, it was pretty easy to see, and we could say, oh, well, I can tell this one's going to be x equals 5, right? And then on this other one, this one, I would add the 7 and then have to take the square roots. So I'm going to get plus or minus the square root of 7. See, really over here, if I were going through the solution process, I would take the 4th root of both sides, and there'd be 2 4th roots, but the 4th root of 0 would still be 0, and then I would add the 5. Okay, so I get a 5 for that first one, and then I get positive and negative 7 for the others. So the 5 was multiplicity 4, positive 5, multiplicity 4, and then I have square root of 7 and negative square root of 7 just occurring one time each. The 5 really had a factor of 4 associated with it, so it occurred 4 times, and then each of the others occurred just once, right? So it would be this one. Okay, so it'd be A.